Welcome to this video on product rule and quotient rule. Now normally I do them in two separate videos, but because of the way they work and the fact that quotient rule is basically product rule but with a small change, they're both going to be done together. I'll do one example of product rule, one example of quotient rule. So we are going to have y equals 5x to the 4 e to the 2x. Now, the way in which product rule works is that you have, if you were to put it in algebraic terms, and you've got y equals fx gx, then that would go down to f dash x, so differential gx, plus fx g dash x. So basically it's, you differentiate one times by the normal one, differentiate the other times by the normal one. That's all. So we go back to our original question, y equals 5x to the 4. That goes to, first of all we have to differentiate the 5x to the 4, which is 20x to the 3, put it in brackets a minute, times e to the 2x. Then this is all plus 5x to the 4 times e to the 2e to the 2x, because that's how e goes when it's differentiated. So that goes to 20x cubed times, 20x cubed e to the 2x plus 5x to the 4 2e to the 2x. Right, that's how product rule works. You can take factors out of it if you want, but I haven't yet come across an exam question where it said they want you to take out factors, but you can if you want. Now we're going to find an example of quotient rule now. Now quotient rule is a little different in the respect that there's basically things on both sides of, it's basically a fraction in algebra. So if we have fx gx, hopefully that's big enough to see, then to differentiate this we must do the same as product rule actually, f dash x gx plus fx g dash x, but the difference is this is all over gx all squared. So we're going to take the example of, let's find something that's reasonably horrific for everybody, because once you can do the more difficult ones then the easier ones become much easier. We're going to do y equals 4x to the 6 over e to the 4x. Now then, the first thing we've got to do is, as I've said, we've got to do the product rule effectively first on the top. So we have, differentiate the first part, so that's 24x to the 5 times e to the 4x plus 4x to the 6 times 4e to the 4x all over e to the 4x squared. So what we've got is, again, we can write this as 24x to the 5 e to the 4x plus 4x to the 6 4 e to the 4x, and then we've also got e to the 8x. Now in this case it might be advantageous to simplify it a bit. We can get rid of 4 to the power, we can get rid of effectively e, we can just scrap e to the 4x, so we just have 24x to the 5 plus 4x to the 6 over e to the, actually no, don't bother simplifying. Reason being is because when you get into powers of e it gets a bit more difficult to simplify. You could take out a factor of that potentially, but apart from that just leave it in the form you've got. You won't be deducted any marks for it. Thank you very much for listening. I look forward to seeing you next time.